In this video, we look at safe coding practices and data consistency. What is data consistency and what is code safety? Let's take a look at some of the issues. Whenever you have an application system, there are some risks associated in making data available. One is that there could be errors that cause the data to become inconsistent. For example, in the middle of an execution, a program might just crash because an operator killed the program, or a hardware error occurred, or whatever, and the data could become inconsistent. Or it could be that in the design, we ship objects, references to objects, to code that is not quite trusted. As an example, in the library system, we could imagine that the user interface could be developed by a third party, and the third party could provide bad code, either intentionally or because the code itself was not constructed properly. Maybe there was no malicious intent, but we could have code that has errors and uses references of objects. For example, you provide a book object to the user interface, and the user interface goes and changes some fields. Those things could result in inconsistency of our business objects. Or it could be that code outside could actually create objects and insert them into the system. For example, the user interface could create members or books on its own, and then use the catalog or member list to insert those objects. What if the user interface attempted such actions? So there are all kinds of issues that come up when you make application systems, when you create application systems. So let's look at data consistency because of hardware crashes. Let's consider two situations. One is very similar to what is in this library. That is, we have disk storage, but we pull all the data from disk into memory, and throughout the day, the memory is from where we retrieve data. In this scenario, an error could happen only if the system crashed. So what you could do is save the data after each transaction. For example, after each issue of a book, or after each placement of a hold, we could save the data. So if the disk doesn't crash, even if the system crashes, that is, you lose power, for example, when we restart the program, everything except the last transaction is intact. The system data that, or for example, in the library data that is on disk is not corrupt. A more realistic situation is when the data is backed up by a database system. In this case, the database management system provides the notion of a transaction, which ensures that inconsistencies caused by programs crashing or system stopping because of hardware errors wouldn't cause inconsistency. So inconsistencies caused by errors in programs because they crashed, or because of hardware errors, we don't have to worry too much. What we have to worry about is The second kind of errors, that is our exposing objects, references to objects, to untrusted code, or code outside inserting objects into the system that were not created internally by the business part of the application. One way of avoiding the problems that we just talked about, that is exposing business objects, is to have for every business object a read-only version. For example, for books, we could have a full book where you allow all accesses, and a read-only book where only getters are permitted. We could do that, but you'll find that the code becomes really hard to manage. So we take a different approach. We have a class called data transfer, using which we ship all data coming in and going out of the library system. For example, in the library system, we will have the business side, which is the library, and then the user interface. The user interface and the library will communicate using data transfer objects. This will contain fields for every kind of information that we want to transfer between the two entities. So for example, if you want to communicate the book ID from user interface to library, we will use this string field, or similarly book title, book author, book borrower, etc., etc. So this is a collection of everything that we want to transfer between library and user interface. And we will subclass this into two. One is result, which is, as the name indicates, the result of invoking an operation. So for example, it has error codes or maybe even an OK code. Okay, and then it has getters and setters for all these, all the fields that you have. For example, there is a result code, which could be any one of these, and there is a getter and setter for this. Similarly, for data transfer, there will be getter and setter for every field. And you can see that result extends data transfer. So every result object will have all these fields plus the result code. So if you want to return, for example, the name of a book, you will have the result code having a value that says operation completed, and the book title will have the corresponding name or title of the book. Similarly, we have a request object that also extends the data transfer class, and this contains things that are going from the user interface to the library, and it contains fields for storing those kinds of things. For example, when we place a hold, we might want to have a hold duration. Or when we want to request transactions on a certain date, we want to say what date we are interested in. So we have a date field, and we have getters and setters for these. So if you look at the implementation of the library system, you'll find that user interface and library communicate using result and request objects. Now, suppose you want to get an iterator to book objects. Instead of providing an iterator to book objects, we are actually going to provide an iterator to result objects. That is, the library system will create an instance of safe book iterator and pass an iterator to books. So inside the library system, we are creating an iterator to book objects and create a safe book iterator object, which has this iterator object as parameter. And what this does is it creates result objects. When the user interface calls next, this safe book iterator is the one on which the user interface would call the next object, next method. So the user interface will actually get an object of type safe book iterator, although it thinks of it as an iterator to results. And the user interface would say next on that iterator object. And what would this next method do? It would check if there is a next element, which is a book. It will check this iterator to see if there is one more book that needs to be supplied. And it simply pulls that book object and sets the result fields with selected book fields. So this method, set book fields, is in the result class. It takes a book object and copies book fields into this result object. And like all iterators, if there is no next book to be returned, it throws no such element exception. Has next, there is one more result available if there is one more book available. So it's a very simple idea. Similarly, we can have a safe member iterator. We could have other iterators. For example, we could have a safe transaction iterator. Another idea that we have here is a filtered iterator. That is an iterator to selectively iterate over transactions or any other object if you want it. So let's imagine we want to get transactions on a specific date. We are not interested in all the transactions. The user interface wants transactions that occurred on some particular date, let's say October 5 of 2018 or whatever, some date. So we don't want to supply all the transactions. We only want to supply transactions on that particular date. So what we use for this purpose is an instance of filtered iterator. So the user interface gets an instance of filtered iterator, which is an iterator on transactions. So how does this work? This filtered iterator gets an iterator to transactions and a predicate object. A predicate is an interface in Java, a generic interface, and it can test whether a certain object satisfies a certain criterion. So the criterion is specified by the client that creates the filtered iterator. It knows what predicate to supply. For example, for transactions, the predicate would be whether the transaction falls on a certain date. So the filtered iterator remembers the predicate and the iterator. And you can see that there is a call to a method called getNextItem. What this method does is it iterates over transactions, which is given here, and looks at every transaction until it lands on a transaction that satisfies this predicate. And you can see that here. While iterator.hasNext, this iterator is supplied by the member object in this case, but it doesn't matter who supplies it. That iterator is used to check if there is a next transaction. And if there is a next transaction, that transaction is looked at and checked whether it satisfies the predicate. So the predicate is also supplied by the creator of the filtered iterator, and the test method checks whether the transaction satisfies the criterion, which would be whether the transaction is on a particular date. And if it satisfies the criteria, we have landed on the correct transaction object and it returns. Otherwise, it looks at the next transaction and so on and so forth until there is no more transaction, in which case the item is set to null. So if you look at this next method, which is what an iterator does to retrieve the next object, if there is no next transaction, it throws an exception. Otherwise, this item is stored in the return value, and get next item is called to position to the next qualifying transaction. And this is what is returned, the next transaction that satisfies the predicate. And we have hasNext. If item is not equal to null, item is set to null if there is no transaction that satisfies the criterion. If there is a transaction that satisfies the criterion, hasNext would return true. And finally, what we want is not to expose even transactions. So we want an iterator that only supplies certain selected transactions, but we want copies of those transactions. So we want to build an iterator that is filtered as well as safe. So we have a safe transaction iterator, which uses a filtered iterator so that it only picks transactions that satisfy a certain criterion, and also copies the transaction fields to a result object. So this is very much like safe book iterator, but it uses a filtered iterator instead of an ordinary iterator. So you should compare safe transaction iterator with safe book iterator. Safe book iterator takes an ordinary iterator because you want to supply every book here and copy that to a result. Whereas here, safe transaction iterator takes a filtered iterator because it only wants to return transaction objects that satisfy a certain criteria and copy those transaction objects to result objects. So the code here is very much like what we have for the safe book iterator. For every transaction, we set the fields of result that correspond to the transaction. So there is a set transaction fields. We are passing a transaction here, right? And because this filtered iterator would be for transactions. And hasNext is simply going to ask the filtered iterator whether there is anything more to supply.